When you're making calculations that involve the inverse trig functions, you need to be really careful to make sure it's making sense to you. Always be thinking, am I looking for an angle here, or am I actually looking for a ratio of sides? And just keep it really straight in your head. Now, you can use these little definitions here to keep in mind. We know that y equals inverse sine x means that the sine of y equals x. The sine of this equals that. But you have to be really careful because we know that we've only defined y as being between negative pi on 2 and pi on 2. Now there's two ways that you can remember these things. So I recommend picking your favourite. Look at the two methods and then say, I want to go with that one. Now this is exactly like when you learn to undo something. Some people are very happy just going with the undoing process, and other people prefer to stick with the doing process and thinking what the unknown is. So a good example would be when you learn to multiply first and then you learn to divide. Some people, when they're asked to divide, are still thinking, if you ask me 42 divided by 6, I'm thinking to myself, 6 something's a 42, it's 7. So it's natural here to want to go back to something that's in your comfort zone. So, for example, with this first one, if I know that y has to be between this and that for the inverse, the easiest way that I have of memorizing it is to go to the graph I'm more familiar with, which is y equals sine x, and remember that it looks like this and that I've decided to use it from there to there. And I remember why I made that restriction. That reminds me that when I'm looking at something like this, I can say the sine of this equals that, but I can remember that this thing over here is an angle, and I can tell because all of this is also an angle, and I can see which angles I can use here because I know that on y equals sine x, everything on the x-axis, they're angles. So that reminds me that my angle has to be in the fourth quadrant or in the first quadrant, and I'm thinking that through every time. Now, many of these you can just punch straight into your calculator. So you could punch this one, in fact all of them, straight into your calculator in degrees mode or in radians mode. What comes out, you'll need to have a think about what you'll need to do with it. Now, these two here are angles, because what this really means is the cos of something equals a half. Now, if you prefer to write this like that so that you can think about what goes in this nice friendly box here, go for it. It's not stupid or anything to do that. You're putting something new and unfamiliar into your comfort zone to think about what the answer could be. And here I know that the cos of 60 degrees is a half. So if I'm working in radians, I know that 60 degrees is pi on 3. So just by writing it like that, I can see that I need pi on 3 as my answer. Now, my word of caution here, you can use your calculator, but you need to be careful when you're asked for exact values in radians. Because if I was asked for exact values in radians here, and I put in this to my calculator in radians mode, what will come out will be pi over 3, but it will look like a nasty decimal in my calculator, and I might not recognize that as pi over 3. Whereas if I just think it through in my head, and I think in degrees, it's 60 degrees, so it must be pi divided by 3, I can get the answer there in my head, and it's exact. And if I've been asked for exact values, that's what I'm going to need. You can then verify these things on the calculator to check that it makes sense. If I was going to verify this, I'd need to make sure I'm in radians mode, though, if I'm working in radians. These questions down here look a lot trickier. We'll deal with those in a moment. This part that's in here is an angle, but then we're taking the tan off the angle or the sine of the angle. So what we're going to end up with is a ratio. So for these questions, it won't matter if you're in degrees mode or in radians mode, because what's going to come out is not going to be an angle, is it? This is an angle, and then you're going to take the tan of it or the sine of it. So what comes out is going to be just a fraction. So it might have surds in it. If it does, then you won't want to be working with your calculator because you won't recognize what comes out as a decimal as an exact surd. So we'll have a look at how to do those with exact values when we get to them. All right, this next one, what this effectively is saying, let me use a different color, is that the tan of something is equal to -1. Now I know that the tan of 45 degrees is 1, so if I need it to be -1, then I need it to be in a different quadrant. So I know that tan is positive in the first and third quadrant, and it's negative in the second and the fourth, but remember our restriction. And I prefer to remember what the tan curve actually looks like, because that's the one that's more familiar to me than y equals inverse tan. I know that, sorry, this should be up there. The tan curve looks something like that. And remember, we decided to use the first quadrant and the fourth quadrant. So here, I don't want the second quadrant answer. I want the fourth quadrant answer because that's the one that we have restricted our domain and our range to. So the fourth quadrant answer that's equivalent to 45 degrees, well, if we're working in radians, 45 degrees is pi on 4. So we need to do 0 minus pi on 4, and what we'll get here is negative pi on 4. And that's my answer. Okay, now for these next two, what I've got here is the tan of the inverse sine of 3/5. Now, what I'm actually going for here is I'm thinking if this question was the tan of the inverse tan of something, and again, I'm going to draw my nice friendly box there because it makes the question feel easy to me. It's a good strategy. I like it. So if I had something like this, then I'd be saying I'm taking the function of an inverse function. What happens when you do that normally? The function of an inverse function or the inverse function of a function, what do you get out? Well, you're putting something through a function machine and then taking what you get out and putting it back through the inverse function machine. You'll be left with whatever you put in. So in other words, whatever goes in that box, it will be the answer to the entire question. So that's what I've got to figure out. So here I'm trying to change this inverse sine into an inverse tan. Now, this is exactly like that trig exercise that we did ages ago when we first looked at advanced trig, which was called given one trig ratio, find another. Now, the best strategy for this, just draw up a simple little right angled triangle and say, look, I've got an angle here. The sine of my angle, because really I could write this whole thing out as the sine of something equals 3/5. Now, this is a different something from that. So, hey, this is where we use algebra. I could call these ones x's, and I could call this a y because it's a nice friendly box, but it's a different thing, okay? So, good use for algebra there. Now, if I know that the sine of something, let's call it y, we'll label that y, is 3/5, then sine is opposite over hypotenuse. I've got a triangle that looks like that, and it's got a right angle in it. So, what would Pythagoras say? Pythagoras would say that this is 4. Looks like a 3, 4, 5 triangle. If it was a more difficult thing to do, I could do my Pythagoras working on the side here and figure out the missing side. All right, now if I know that the sine of y is 3/5, what would the tan of y be? Well, tan of y is going to be 3/4, isn't it? Okay, so if the tan of y is 3/4, can we write that around another way to get y as the subject? Of course we can. We can say that y is equal to, sorry, I'm sort of working down and across here because I've run out of space. Y is equal to the inverse tan of 3/4. Now, see what I just did there? The tan of y is 3/4, so y is the inverse tan of 3/4. So I've just figured out what y is. It's the inverse tan of 3/4, but it was also, remember, the inverse sine of 3/5. Remember, that's where I got y from in the first place. I defined this whole thing here as y. So effectively, I've just changed all of that into this. And the thing that goes here in what was my nice friendly box is 3/4. So the answer to the whole question is 3/4. Now you can check that, whoops, doesn't need brackets, by putting it into your calculator right from the start in degrees mode or in radians mode, and it's going to come out as 3/4. Now, I can already hear you saying, why didn't we just do that then? Well, I'm showing you the method that I'm using here on this one with one that's got nice, simple numbers. So that when we do the next one, which isn't going to come out so nicely, we've got a method to follow. All right, so let's make a bit of space and do the last one here. So that was our answer to that one, was 3/4. Now, same strategy here. I've got the sine of the inverse cos of something. So what I'd really like is I'd like the sine of the inverse sine of something. Let's use our nice friendly box again, because I think that's quite a good strategy. Okay, so this whole thing here is an angle, isn't it? What is the angle? Let's call it theta this time. Let's make up a triangle. We'll whack theta in, a right angle in there. And we'll say, okay, if the inverse cos is negative a third, then what that really means is that the cos of theta equals negative a third. Now, we'll deal with the negative in a moment. Let's just pretend it was cos of theta equals a third, so we can get the sides right. If this is theta, cos of it is going to be 1 over 3. Figure out this side using our Pythagoras. We can see that 3 squared, that's 9, minus 1 squared, 1, is 8. So if this side is squared to make 8, it must be the square root of 8, which is 2 root 2. And if you don't like doing that in your head, by all means, do your Pythagoras over on the side there. Okay, what have we figured out? Well, the cos of this angle theta here is 1/3. So what would the sine of that angle be? It would be opposite over hypotenuse, wouldn't it? So 2 root 2 over 3. Now, I can hear you saying you never dealt with the negative over there. You're right, I didn't. I just held it back for a moment so I could work out what digits I need, and then I consider whether I need a negative out the front. Now, what is our restriction when we're dealing with inverse cos? How did we restrict the cos curve? Cos curve looks like this, doesn't it? Goes on and on in both directions. But didn't we use just here to here, the first quadrant and the second quadrant? That's a good way to remember what we're doing. So now when we said, hey, the cos of something is negative a third, what could that angle be? I can tell that if cos is negative, we must be in the second quadrant, okay? So if we want to find the sine of that same angle, and we know it's a second quadrant angle, let's consider, is sine positive or negative in the second quadrant? It's actually positive, isn't it? Think of your all stations 2 central. So in fact, this is going to be positive. It's not going to need a negative at all. Now, can I convert this so that it's in the form theta equals something? Of course, theta is going to be the inverse sine of 2 root 2 over 3. So it's 2 root 2 over 3 that goes here in my nice friendly box. And in fact, now I've got the situation, the sine of, the inverse sine of something, the answer is just going to be that something. So we get 2 root 2 over 3. Now, if we've been asked to do this with exact values, and we put it in our calculator, you can verify right now, if you like, in degrees mode, and then do it again in radians mode, and you'll see that what you get is the same thing as 2 root 2 over 3, but when it comes out as a yucky looking decimal, you wouldn't necessarily have recognised that that's what it was. So you need to follow through this process so that when you've got one with surds in it, you're going to know what to do.